Hello, everybody. Welcome to our webinar today on AI in the manufacturing industry. Thank you so much for joining us. Before we get started, it looks like people are still funneling in to the room, but I wanted to let everyone know we are recording the session today, and we will be emailing out the recording and a copy of the slides to everyone so you can have it to review it or share with your colleagues. We also will be taking questions throughout the webinar and at the end today. So if you have any questions, please submit them in the comments or the Q&A section, and we'll be sure to get to them on the webinar today. So let's go ahead and introduce our speaker, Dr. Tim Oates. Tim is the co-founder and chief data scientist at Synaptic. He has over 20 years of experience in guiding organizations and companies of all sizes, applying AI and machine learning to business problems across industry. He earned his PhD in computer science from University of Massachusetts Amherst with a focus in AI and machine learning, and was a postdoctoral fellow at MIT AI Lab. Thank you, Tim, for joining us and speaking today. I'm going to let you take the presentation from here.
Okay, thanks, Sam. So I just want to start out with 2 minutes on our company. So as Sam said, I'm the chief data scientist and co-founder at Synaptic. We started out a number of years ago doing kind of AI and machine learning consulting. So it was all work for hire, where we'd build a system, hand it off to a company, and then they would integrate it into their internal processes. Over time, though, we've grown to build more of what we call intelligent products. So we do a lot of work these days still at that core business, which is what I really enjoy doing, is kind of the machine learning and artificial intelligence to solve business problems. But we have a lot of people on the team who are experts in product and user experience, and we sort of manage the process end to end these days for many of our clients, which is actually kind of gratifying to be able to see something get deployed and have an impact on internal or external users. So, a little bit about the company. So, the outline today is pretty straightforward. It's AI in manufacturing. I got a couple of thoughts on, why is manufacturing a great place to apply artificial intelligence and machine learning. I actually learned something I didn't know before in preparing for this webinar that I thought was kind of interesting. And then I've got a few case studies. So we'll talk about predictive maintenance, machine vision for quality control. Uh, Maybe a slightly seems orthogonal, but I think this is kind of interesting, writing proposals faster. So can you, if you get, somebody says, "Hey, I'd like you to give me a bid or proposal for manufacturing these widgets," how can you get that done effectively and more quickly? And then we'll talk a little bit about digital twins, and then we'll kind of wrap it up and sort of try and tie the things together. So, um, first of all, why manufacturing? So it turns out, so this is the thing that I learned. I found this chart which I thought was fascinating. Machine learning, the success of machine learning and AI these days is driven by three things, two of them really important. The first is lots of data and lots of compute. So there's this old paper that was written a while ago called The Unreasonable Effectiveness of Data. And what that paper said was essentially you had a whole bunch of machine learning algorithms. If you don't have much data, the choice of the algorithm matters a lot. And so you kind of have to be smart about how you use that data. But as the amount of data that you gather increases, you can use sort of any old algorithm for certain purposes, and they all tend to work pretty well. And so the conclusion was, if you don't have much data, you got to be smart. If you have a lot of data, you can not think quite as hard and just let the machine grind on it. So if you got a lot of data, you can do really interesting things. You need a lot of compute to be able to manage that. Those are the two things. And then there have been some really interesting innovations on the algorithm side over the last, 15 years, which have clearly been super important. But it really is sort of data is the main thing. And this chart just shows, hey, in terms of petabytes per year, which is a petabyte is a ton of data, how much are various industries producing? You can see healthcare over here is at 375. And I would think, oh yeah, that makes a lot of sense. Healthcare is going to generate a lot of data. Retail is going to generate a lot of data. Banking, yeah, I could see they would generate more, but manufacturing is by far the biggest producer of data out there. So what that says is that there's probably a tremendous amount of opportunity. There are lots of manufacturing concerns that are gathering lots and lots of data. And so the question that we're going to kind of dig into today a little bit is what can you do with that data when you have access to it? The other thing that I thought was interesting was this chart, which looks at the sort of AI and manufacturing market. Here we are in 2023, and it's about 3.8 billion. And notice it's broken out into software, services, and hardware. And the projection here, and I looked at a few of these kinds of projections, says it could be up to about 156 billion by 2033. But every chart that I looked at, you can't trust the raw numbers, but the trend is always a sort of like exponential growth in the application of AI in the manufacturing market. So I believe that there are a lot of places where AI can help manufacturing, and so we'll talk about a few of those. So as my outline said, I'll start out with predictive maintenance, and I've done some work in this in a variety of capacities. So in manufacturing, you have machines that are doing things, and you can think about three different kinds of maintenance. There's preventative, there's reactive, and then there's predictive. And so predictive is where we'll spend most of our time. But the idea is I've got some machine and it's sort of, grinding away, doing its thing, and it seems like it's fine and there's no need for maintenance. At some point, it's like, okay, that machine's been running for a while. Maybe it's starting to act a little funny, right? But the idea is that it's not something that you and I could sense. But maybe if we put other kinds of sensors on there, so maybe if we had a vibration sensor, or we were monitoring the power draw on that thing, or if we had some infrared sensors to be able to look at the heat signature of it, we might be able to send signals or sense signals that would be triggering of us saying, I think that thing might be getting into trouble. Maybe we should do something about it before we get into the reactive problem, right? So everybody's had a thing where suddenly the sound changes, or it gets really hot, or there's an odd smell coming from it. And at that point, you don't have to be an expert to go, yep, that thing's in bad shape. Let's do something about it. And so what we want to do, and what a lot of people think about in manufacturing and other industries as well, is to go from preventative maintenance to a more predictive paradigm. We'll talk about why that might be important. So, um, predictive maintenance, then you can just think of that as saying, I'm going to attach some sensors to a device. I am going to try and use that data to identify when it might be heading towards a problem and intervene before the problem actually arises. So, if I can be proactive, I can avoid shutdowns, which are going to cost money. I might even be able to avoid unnecessary preventative maintenance. So, I think in many circumstances in manufacturing, you're very careful. You don't want downtime on the line. And so you're going to be doing maintenance on a very fixed schedule. But it could be the case that there are certain machines and I've even seen this, that machines in different locations in a factory floor will behave differently just because of the different environmental conditions that are there. So maybe I need to maintain certain machines more and other machines less. Also, you can increase the equipment lifespan. So if the idea is that you're sort of going, something's going on, let me go ahead and do maintenance on it, even though it might not be called for now, I can prevent damage to it. And then again, you get this improved operational efficiency because there's less disruption to the machines. So I want to talk now about a really simple case, and this is actually some real data that I worked with at one point. It was a system that had a data acquisition system. There were 653 binary sensors that were measured every 1 millisecond. So you're getting 1,000 samples a second, and there are 653 of these sensors that are just churning out that data. And it turned out that in talking to the domain experts, what these sensors were doing was they were essentially tracking kind of switches changing inside the system that we were monitoring. And so good behavior is you go, hey, change state, and it goes, okay, boom, I've changed state. Bad behavior, because this was a physical mechanism, was just like, oh, I'm trying to change state, and like I'm not quite succeeding, and then eventually I kind of latch into it. So one approach that you can take, and we'll come back to this term just a little bit later, is supervised. So supervised learning is where you say, here's some data, and I'm going to label that data. A human expert's going to look at this and go, okay, here is 3 samples of that system where everything was fine. Here are 3 samples where things were not fine and where actually there was a problem that probably should have been attended to. And then what machine learning systems can do is they can take this data that's been annotated by a human. You can use an algorithm of an appropriate kind, and then take that algorithm to learn a model that takes new data and says, yep, that's good, or nope, that's bad. And so the idea here, and again, a thing that we'll return to a little bit later, is that you need to have a human expert go in and annotate these things. And in particular, if failures are very rare, which you hope they are, then sometimes finding that failure data is going to be costly. So that's one approach, which is it's supervised because a human comes in and goes, here is the correct answer. If you see this data point, this is what you should say for that. This is the machine's working fine or the machine is not working fine. Another approach is anomaly detection. So if you believe that most of the time your machines are going to be operating smoothly, what you can do is you can just gather a bunch of data. And by that assumption, with very high probability, that data is going to be from a good operating regime. And then you can take new data that's being produced and look for outliers, look for anomalies. Does this thing look like the data that I'm seeing normally when the machine is operating well? And if it doesn't, then maybe I need to signal somebody to take a look at it. So what are some of the considerations when I look at these kinds of problems and I talk to people in industry and they go, we'd like to do predictive maintenance. I say, well, let me talk to some smart person who's been working with that equipment for 40 years. And that's a little bit of an exaggeration, right? But usually there's somebody who's worked there for some number of years and they've got this weird sense for, yeah, I don't know, man. I think that machine's not working quite right. So the question is, what are they paying attention to? What information would they need? And if it turns out that a human thinks, yeah, I think these are the kinds of signals that we're going to see, chances are good that you can use an appropriate amount of data to train up a machine learning model. So it's just like the human expert on the data I was showing you before said that that chatter, that sort of attempting to transition and then finally being able to transition, that tells that human expert that a problem is on the horizon. So, then you got to think about ROI. What's the cost due to downtime? Are failures common, uncommon? But then also, if you're going to use a machine learning approach, you're typically going to need to add some instrumentation, some sensors, a vibration sensor, an infrared sensor, and have to be able to store that data. So again, for that aforementioned project, they're cranking out 1,000 signals a second. There were about 650 of those sensors. That's a ton of data to deal with. And then, you can kind of trade that off against the increased uptime. Then you have to think about what's an appropriate approach. Will I do the anomaly detection approach? That is, I don't know, does this look weird compared to what it normally does? Would you use supervised learning, which means you need an expert to come in and kind of label things as to whether they're okay or not okay? And then sometimes just data visualization is good. Sometimes it's enough to say, hey, expert, can you just come in here and like watch this machine run for a little while? We're going to stream some sensor data by you. And often they can go, yeah, I don't like that. That looks bad. We should probably take a look at that machine. All right. So the next topic I want to talk about is machine vision for quality control, which is a problem at Synaptic that we've talked to lots of people about. And so the idea here is that you're going to use computer vision methods, which are in the context of modern day AI and machine learning, it means you're going to take a deep neural network and you're going to take images as input. And what you'd like to do is to have the system learn to look at an image and go, there's a problem or everything seems to be okay there. So it turns out that in radiology, for example, there is so much radiology data that has been looked at by human experts that there are machine learning based systems that are as good as those human experts. And so again, the idea is we're doing it in this kind of supervised learning sense, and we have lots of data, and that seems to be, or is typically the key to success. So why does it matter? You can have consistent inspection. It can be the case that that machines trained with enough data of the right kind can probably find flaws that humans may miss. If we have time at the end, I'll tell you about a project that we did a long time ago trying to detect whether two comic books were the same comic. All right, I'm going to show you a comic book, and then a year later, I'm going to come back with that same comic book. Is it the same comic book you showed me a year ago? Turns out we used machine vision to solve that by looking at very tiny imperfections on the pages. Anyway, so if anybody cares, I'll talk about that later. Also, these systems are scalable and fast, right? So you can look at all the items as opposed to, which is very common, is I'm just going to take a sample of them and see if any of the samples are bad. You can reduce waste. If I can detect defects early in the process, then I don't have to trash the entire product at the end. And then it just sort of allows you to do all kinds of interesting things by looking at analytics. Maybe it's the case that When Tim is running the machine, there tend to be a lot of defects, or maybe that machine over there is producing a lot of defects. And so we should, maybe train Tim up on how to be a better user of that machine, or maybe we need to do some work on the machine. So here's a couple of example domains. I'm showing you these because I'm going to talk about two ways of solving this problem. One is that supervised learning thing that I talked about, and then the other is let's see if ChatGPT can do it, and then I want to talk about the trade-offs there. So, on the left we've got wood grain, and we want to be able to not have imperfections. We'd like a machine to look at it and go, "Yep, all that those bottom three have problems." Here's some fencing, and if you look carefully here, some of these things are bent. The defects are more obvious here. Pills, like pharmaceutical industry, quality is super important. You don't want there to be cracks or holes poked in it, or these things kind of crimped or squeezed. Here's some material like leather, and then here's another food item, right? So sorry, another pharmaceutical item. So the problem then is, if I got a bunch of data like this, kind of have a system look at it and go, good, 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 and then here's a problem. Here's another problem that we talked to a company about for a while. This is not manufacturing, but it's very similar in spirit, which is airplanes. When they come in, they're often inspected, and they have human inspectors that will sort of go over the skin of the airplane looking for all kinds of defects. And so this company was trying to get actually drones in this case to sort of fly over and around the airplane, build up a 3D imagery of it that's high resolution, and then look for all kinds of problems on it. And it turns out that there are these technical terms, like there's a paint bulge, there is a scratch, which is different from a gouge, which is different from a chip or a peel. So there's bird strikes and things like that. So in this case, what they were doing was they were building a training set. So here's examples of paint bulges, and here are some chips, and here it looks like there was a lightning strike. And again, the idea was, can we do this in a way that's more scalable, more efficient, and maybe less error prone than having humans in the loop? So, how do you do this? I want to talk about one slide on how you do the supervised learning approach to it. Um, and then let's see what ChatGPT could do with it. So, this is supervised learning, but it's what's called active learning. And active learning is often very useful in situations where your domain expertise is precious, right? It's hard to get the domain expert to sit down. And furthermore, you really don't want to have them sit down and like wade through 5,000 images to find the 10 examples of defects. And so what active learning does is it says, okay, we've got some data, what the human expert sat down and, I don't know, gave us 20 good images and 20 bad images. And then we do the machine learning thing, which is we use that data to train a model. And what that model does is it says, for new images, I think this thing shows a defect, or it doesn't show a defect. The other thing that these models do that they output is usually a measure of certainty. So I could be 99% sure that there is a defect there, or I could be 60% sure that there's a defect there. And so what active learning does is it says, you gave me a little bit of data. Now what I'm going to do is I've probably got a boatload of unlabeled data around, right? Just images I'm gathering, but no expert has looked at. What I want to do is I'm going to push those through the model and see what it thinks. And what I'll do is I'll grab the images that it's really kind of uncertain about, right? It could be a defect, might not be a defect, and we'll hand those over to the human expert. And so what that does is two things. One is it gives you data where the model really needs it the most, where it just really is unsure as to what's going on. But then the other thing it does is it allows the annotator, the human expert, to be used in just those situations where there is data that can be pulled in from that massive unlabeled data. So the human expert's not there scanning through thousands and thousands of pictures. They're looking at ones that matter, and that can make the process go much faster and be much less painful. So supervised learning, often the way this is done, active learning is a way of kind of maximizing the time that your human annotator spends working on it. Okay, so then I'm always curious, what can ChatGPT do with it? So what I did was I took these are the pill pictures that we saw before. And again, I just grabbed those randomly off the internet. Notice what I did was I actually masked out. So they've got a good crack, poke, squeeze. No doubt ChatGPT can see that. And it would use it. So what I did was I just went in and edited the image and removed that. And so I said, the attachment has images of pills. The top image is a pill with no defects. For all of the other images, can you say if the pill has a defect or not? And if it does, describe the defect, right? So, and I wasn't sure. I don't know, but I'm always surprised by ChatGPT. So notice it goes second image, first below the reference. Yes, the back half of the capsule is broken open, and some internal metallic looking component is exposed and protruding. I'm hoping it's not metallic, but you get the idea. Physical damage. The third image, yes. The text, 500. Let me just look. Is it 500? Yep, that's right. So it read the text off of it. Um, Partially obscured by a white smudge or foreign substance, could be a contamination or manufacturing printing error. And then the third one, yep, it appears crumpled or dented on the orange half. Check it out. It's like crumpled and dented, and it's telling you what half it's on. So, like really amazing. I did one more trial. I took the fencing because I have to say, the first time I looked at this, I was like, I don't see what's going on there. And it turns out if you look carefully, you see a few little defects. So in this case, I did a couple of things. I said the attachment shows images of fencing from a manufacturing plant. Can you look at each image, right? And so I also had it's ungrammatical, but ChatGPT doesn't care. It figures it out. Say whether it shows a defect or not and describe it. So in this case, I didn't say this one is good. Tell me about the others. I just said, hey, it's fenced. Do you see any defects in it? And it does really well. It says, no, there's no defect in the top image. There's several small dark marks or inclusions across the surface in the second, tears or holes in the third, and there's a dark smudge or blotch in the lower right region. Notice it got it. It's not, I can't remember what that is. It's called threading or something like that. But the idea is it's able to look at these things and notice this is happening with zero training data. It's just smart enough to be able to figure that out. So then, if you want to, it actually came back from this query and goes, hey, would you like a table? And I was like, yeah, give me a table. And so now what it does is it gives you the position, a column for whether there's a defect present or not, and a description of it. And then it also goes, do you want that in a CSV so I can load it into a spreadsheet? So language models like this, incredibly useful. Hang on, let me see if I have another slide. Right. So let me say something about that though. Um, if you're a pharmaceutical company and you are using Chat GPT to do quality inspection for the pills you're manufacturing, you're crazy, right? Because um, it'll do an okay job and it'll be very impressive, but you don't have the level of control that you need in that situation. So if it's a sort of a niche problem, if you really, really care about it being right, then the supervised learning approach is probably going to be much, much more effective. However, if it's something where again, you're taking samples of fencing, you could imagine setting up a system that just kind of hands it off to something like ChatGPT and says, what do you think? And evaluate it, right? You have to evaluate it carefully. But it is the case that if you really care about accuracy and throughput and typically kind of managing costs, and you've got the data, training a model on your own is probably going to be better. So, and then this last slide in this section here is just lots of industries: automotive, semiconductor, electronics, general purpose manufacturing, lots of areas of application. I've seen lots of examples of sort of looking at machines, for example, that are painting, seam inspection, lots and lots of applications, lots of use cases. And then there are just many, many commercial products that are in this place. So uh, this sort of quality control is a great area to think about. Now, I've got two more sort of much shorter segments that I'll talk about. One is writing proposals. And so I'd be curious to know if anybody who's here actually has to write proposals or sort of bid on manufacturing contracts. But so it is the case that if you're in that business, looking through RFPs or requests for proposals can be incredibly time consuming. And what you can do is you can use a large language model to kind of get you to an effective response faster. So there are kind of three things that they can do that I think are very appropriate uses. One is I can just say I've got an RFP. Somebody wants me to make a bid on manufacturing, I don't know, 10,000 units of whatever it is that I make. So you can extract information from the RFP so that you can understand it more quickly. You can create a skeleton proposal very fast with a language model. And then often if you've got boilerplate, so many RFPs, they want to know something about your company and its size and its revenue, how long it's been around, um, background on what it is that you manufacture, then that information can often be pulled from company documents. So here's an example, found a, wind turbine improvement project where people are bidding on manufacturing wind turbine parts. So, you can go to ChatGPT, and if you haven't done it before, there's like a little, I think it actually turns into a plus icon down there, but it's like, okay, I'm going to upload a PDF from my computer. So I just said, here's the RFP. I'm going to upload that thing. And it goes, okay, thank you. And so I say, when are proposals due? And it turns out that these, due date was May 10th, 2024 at 1 p.m. local time. So the idea is it can look inside that PDF and just you can ask it questions. And so if you want to know like when's it due, are there page limitations, whatever, you can start just kind of talking to the large language model about it. Did I say, well, how are proposals evaluated? Be brief. Turns out there's, understanding the project, experience qualifications, past performance, blah, 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 cost effectiveness, and then, oh, it looks like the shortlisted offers are going to, sort of give an oral presentation. So that's good because now I kind of understand what's going to be important here. And notice I said be brief because the first time I asked this query, it gave me sort of 2 pages of content, which was just overwhelming. So kind of, have to know how to talk to your language models. And then I said, create a skeleton response to this RFP based on what they require. And it goes like, great, right? Here's a skeleton response. And notice what it's doing is it's saying, oh, we have to have a technical volume or volume one of the technical proposal. Title page and content, it's got to have this stuff. There's an executive summary. There's some required documents that have to be attached. And so, interestingly, what you can do is use that just as a framework for doing it. Now, again, you have to be careful because LLMs are very well known now. They'll make things up occasionally. Although I think that's getting a little bit better in circumstances like this, which are so for example, information extraction and document summarization, they tend to be quite good at that. And I think that the number of hallucinations tends to be smaller. But you go, okay, great. Here's the stuff. Then it's possible to say, here's like a bunch of documents I've got. So, I've got a bid proposal affidavit, or I've got where's my Maryland operating license? Then you can have the LLM sort of give you an initial draft of the thing. And, for me, there's a sweet spot in there when I'm trying to generate text of some kind where, I don't want it writing the whole thing because it's not my voice. It's not how I would say things. I'd like to think I'm a better writer than ChatGPT is, at least for today. But it's often really useful just to say, can you give me a high-level sketch of what it is that I need to write? And if there's just something that you can find in our corporate documents, like fill that in. That would be fine. Trust but verify. So, what are considerations? When is the size of the team and the scale of the effort? So if it's the case that it's just one person, you're the person and you're going to respond to that request for proposals, then, slurp it into Chat GPT, just ask some questions about it, get it going in the right direction, ask it to generate a template, and you're good to go. However, if you're going to be doing this a lot, or you're going to be looking at a lot of RFPs, then that might be hard. And then also the kinds of documents that you're going to use have an impact on it. So, would you use ChatGPT or some custom tool? And there are tools out there that you can, purchase to help you with this kind of thing. Is it all ad hoc interactions, or do you need to store things in a database, right? Is it going to be a lot of people doing this, or just sort of one person? Is it going to be a lot of documents or not? And one thing that I find in a lot of industries is that sort of corporate voice is really important. So I see that a lot in the legal industry where the way the lawyers write and the way they tell the stories that they do in the legal documents they view as a competitive advantage. And so turns out that if you have lots of past proposals or and bids or the things that you wrote in response, you can actually use that as examples of your corporate voice and can be somewhat successful in getting a language model to write it like you would, right, with the appropriate tone. Okay, so that's another thing. And then the final topic I want to talk about today is this notion of digital twins. Um, and so what's a digital twin? And then I'll just talk briefly about a little personal experience with it. Um, in so the real world is hard. I actually, for my PhD, I did work with physical robots, um, and they always break, and they're hard to control, and the real world is messy, and nothing ever goes the way it's supposed to. I mean, it's interesting, it's a fun challenge, but um, the real world is a hard place to work. And so, if you've got a manufacturing floor, for example, where you've got physical devices that are doing things, and you're thinking, "Hey, I'd like to make a change of some kind," wouldn't it be way better if you could sort of experiment with that change in software, which is going to be fast? You can cycle on it really quickly. If your change was ill-advised and it would break the entire flow of things, it's okay because you broke it in software. You didn't sort of bring the plant crashing down. And so a digital twin is nothing more than a sort of a software artifact that behaves a lot like the physical hardware artifact does. And it's informed by data, right? So the idea is that you're gathering all this data. We saw there's 1,000 petabytes of data every year coming from the manufacturing industry. Then what I can do, I can put sensors on there, and then I can gather data. I can use that data to construct this digital twin, right? I want this thing that behaves like the actual physical system does in the same situations. But then I can do things like data analytics, I can build simulations, I can monitor performance. And then, based on what I learn in software, I can go back and do optimizations in hardware. And the idea is that you hope that there's enough fidelity between the digital twin and the sort of physical side of things that the changes in the experimentation that you're looking at on the software side are going to be close enough that they will have similar effects on the hardware side. So I actually have interacted with some people at GE Research. It's now GE Vernova, which is their aerospace side, and they build digital twins for their airplane engines because those things are incredibly expensive. And when they build a new one, when they construct a new engine, they design it and they build it, they really need to be able to test it in software. They can't afford to have these things go out into the field and have any flaws or defects or failures. And so they're very careful about constructing digital twins and doing a lot of experimentation on them prior to sending the physical artifacts out there into the field. And so there are lots of situations where, a failure is so expensive in terms of money and potential loss of human life, you have to do it. Or if you build a digital twin for a manufacturing plant, it allows you a lot of freedom to sort of experiment with different configurations. And so, again, the way to think about this is sort of saying roughly the same thing, is that you've got the kind of physical system that's providing a bunch of data to help you build the digital twin, to analyze the digital twin, right? That can be used, the data can also be used to build models and drive AI systems that are going to be proposing enhancements to it, helping you make decisions about how you might want to change that underlying physical system, which then feeds back here. So, like we talked forever about digital twins in manufacturing, but again, of like very, very common application. Oops, sorry, going the wrong way. Okay, so just a few more thoughts. One is again the sort of the future looks very bright for AI in manufacturing. On the left-hand side is that graphic I showed before, which just suggests that if you take one qualitative thing away from it, people are going to be investing a lot in the next decade or so on AI to help with manufacturing. Now, the graphic on the right is another one that I found, which I thought was interesting. So, a survey was done. People chose their top three reasons for investing in AI and manufacturing. And I think it's really sort of interesting. Reduce cost and improve operational efficiency. 72% of the people were like, yep, that's it. They want to improve operational visibility. So they want to reduce costs. They want to understand what's going on. and then this sort of improved process optimization and control. So these top three are all saying basically the same thing. We want to reduce cost, we want to be as efficient as we can possibly be, and we want to know what's going on all the time. These sort of downstream things, like improving quality was only 22% of the people. So it's a thing that can be done with AI. I want to improve customer experience. I want to compensate for labor shortages. But really, when people think about AI in manufacturing, they're really focusing on I need to be efficient, I need to be transparent, and I want my processes to flow as smoothly as they possibly can. So, how to get started. Like all these webinars, I tend to end in this way just because it's a very general thing. Like think about your pain points. So often companies will come to us and they'll say, yeah, we think AI can help. And so the first thing we do is they say, well, how do you think it can help? What are the points in the system where you think it might apply? And they invariably have tons of idea about those kinds of things. Um, I do think it's important to work with a trusted partner to explore feasibility. So when I talk to clients, believe that the color of my beard, which is gray, it's a feature, not a bug. That is, I've been doing this for a long time, and so I have a good sort of intuitive sense for what problems feel like they're tractable, how much, grip can you get on it? Will it be easy to solve it? Will you be able to sort of make significant gains? Think about what your data looks like. So again, if you got a petabyte of data, that's great. But if it's a petabyte of data that's spread out over 10 different physical locations in different formats, there might be a lot of work that needs to be done. I would also say on that, I also run into companies where people will go, oh, our data's a mess. We've got to have a data lake. We've got to get it all sort of sorted out before we do anything with AI. And I'd say that's not necessarily the case. It goes back to the sort of first point, which is what are your pain points? Not all your data is going to be relevant for every pain point. So I think it's worthwhile to say, let's think about the places where we think we can have significant impact, look and see what's data is necessary for that, and then look at the quality of that data as opposed to trying to get the whole thing sorted out. Um, then you got to think, is technology ready for that problem? That's less of an issue these days. I think we've made so many advances in machine learning and AI that certainly there's some problems that are, still going to be too hard. But I think the space of things where AI can have an impact is really large. And then the last one is you got to look at the ROI because often we deal with people who are technical or kind of tech evangelists. And often the CEO is like, well, I'm trying to run this company and make money. That AI thing is interesting, but I don't really understand how it's going to help us. And so I think if you're a person inside of a company, you're doing manufacturing, and you think AI can have a significant impact, you got to have the ROI story clear, and then that can help you get stakeholder buy-in from people at kind of all levels of the company. So. Okay. Thank you very much. I appreciate you attending and listening. I would be happy to take any questions if there were any.
Thanks so much, Tim. That was a great presentation. We haven't had any questions in so far, but if anyone has any, feel free to pop them in the Q&A. And in the meantime, as a reminder, we did record this presentation. We'll be sending it out via email, and we'll be sharing it on our social media pages as well, and along with a copy of the slides, so you can review the information and you can share it with colleagues as well. And if we don't have any questions, we can go ahead and wrap up. Thanks everyone for joining us and hope you have a good rest of the day.